there is no way bank. If you have not done banking, you would not have any transaction history. Thus, you will not have any credit rating available with the standard credit bureaus. Many of fintechs are trying to tap that part of the population. Yeah, but it's not easy as it sounds, because when you give loan or credit to your customers, you want them to pay back. So the first problem fintech face is how to lend with confidence in new to credit market. The customer you are giving loan to does not have much credit history. So how do you access the credit risk? Or if you're running, if you have already started business and you are giving a loan to a small section of people, how to increase your loan approval rates without increasing your risk significantly? And the third problem is how to reduce the credit fraud during collections, because in these countries you would notice that many of the customers do not pay back the loans. This is something which we are not going to cover today, and we'll focus more on the first two. A typical lending funnel looks like this. So on the top, you have thick file customers about which you have a lot of credit history, a lot of transaction history, and it's easy to assess those people. And most of the fintechs or the banks or the financial services company would give credit products or loan products to those thick file customers. So in finance parlance, those are called thick file customers. Then you have thin file customers where you have little informations. So the companies are unsure whether to give loan or not. Then you have no file customers. No file means there is no information available and you reject the loan. Okay. So what companies have started doing is the companies are venturing into alternate data. They are if everyone keeps a smartphone for instance. Now your smartphone generates a lot of app usage data, location data. Everyone uses the telco products like in Singapore, you can say StarHub, Singtel. You will have a call history, or people pay their utilities bill, etc. So companies are venturing into this space and trying to make advantage of using this data, because the transaction history is simply not available with the banks. Okay, so these companies enrich the customer profile using this device level data or telco data or utility data. So this slide will give you a snapshot of how it's done, what kind of data is being used by these lending companies. So as I was talking about device information, now everyone keeps a handphone now. I mean, you may not have a banking product, you may not have an account in a bank, but you will certainly have a smartphone. Now, once you have a smartphone, you're going to generate app usage data. What kind of apps you use, how frequently do you use? Let me give an example. If someone is using gambling apps, this gives you some insights about the person, as versus somebody is using news apps. Now, if you have a smartphone, you will surely be generating telco data. In fact, many of the companies have partnered with telco companies to get telco data and to do the risk rating. Then you have utilities data. Then you have location data. So companies are using one or a combination of multiple data sets to come up with alternate credit score. So at this point in time, I want to introduce Mobile Wala. It's a consumer data and intelligence company. So we help our clients to make most out of their data and AI investments. So we are present in 40 countries. We have 2 billion profiles. That the kind of data we deal with mostly device data and app usage data, location data. I'm telling you now because in few minutes, Georgia is going to take you with a real case study where he'll be making use of these data sets. So we identified this need as well, that fintech wants alternate data, and using our data sets, we have created a product called Lend Better. So if you look at the credit funnel again, this is how it looks like. So thick files were already approved. So there's no impact to these thick file customers. Then you have thin file customers who do not have much information, but we provide additional information about these customers. Then no file customers, though those customers are still generating some usage data, device usage data. Okay, so you will have a lot of data points to gauge the credit risk of these thin file and no file customers. So if you look at the slide, you see that Lend Better, our product is called Lend Better. This fits here, wherein thin file and no file customers can be gauged. The credit risk can be gauged. So with this, I'll pass the baton to Shorja, who will explain how credit risk modeling is done. Shorja, up to you.
Thanks, Pratik. Hello everyone. Very good evening to all of you out there, and it's really nice and privilege at the same time to be a part of this event today. And I really look forward to brief about some of the practices we do from data science side, and also answer questions in particular if you have any. With that, I'll start off with my part. Yeah, I mean, I largely cover the objectives per se, and as mentioned in this slide. So we have been solving mostly the two problems. Firstly, specific to assessing the creditworthiness of the new customers applying for credit using LendBetter, and secondly, to measure the predictive power of the features which we uh, typically use for solving the different use cases. Uh, Now, I'll uh, have some kind of a debrief on the process which we typically follow in house, and as a part of our execution process. So we have four components here primarily. Now it's very obvious that I'll go one by one. So it's very obvious that the ingestion and the different charterings will be at the first run. So this includes the place where we do a bunch of analysis like match rates and looking at different data snapshots and then come up with the best representative match to serve the specific input data. So precisely all the different data related scoping is done, and that's the same uh, scope which we eventually use it for the subsequent modules. Now, next we have the component wherein we have the very popular trio in a typical DOS pipeline, as we know them by the different processes like the pre-processing, modeling, and validation. So, so this step is also ensuring to this fact that the model is finalized here, and we have some sort of an endpoint in place which can be eventually used for deciding uh, what I mean eventually used for deciding what a model to be used for as to be applied on the test data set. So this is what we do here, and alongside we also have a bunch of evaluations done on the features which we uh, we have evaluated as per the significance, and particularly the model significance here. And once everything is done and finalized from this step, we eventually use it to share it with the client through our API. And as mentioned, there are a bunch of steps here. So we have our API built, and here we primarily support the different data feeds as well as the risk scores which we generate from the model, and eventually they are being exposed, and the client can always do API calls, and the desired data can be returned by us. Now, lastly, we have uh, a robust production support system, I would say. So this production support caters to multiple things. So it's not that once a model is built and we have shared data with the client, and we not do anything. I mean, even if the client doesn't respond back on any feedback, particularly if the model is working out or not. But we always try to make sure that whatever model comes out of our system or our environment, it's always sustainable, and we do a bunch of validation checks periodically to make sure that the quality of predictions are kind of sustainable, and also in terms of the features which we have, the features are also exhibiting the right stability. So there could be a possibility that the features could be unstable, just like that, and because of XYZ reason, there could be a possibility that the features can uh, go follow a different distribution altogether, and that can definitely mess up the entire pipelines, right? So just to avoid this downstream at a more prospective level, we try to make sure that we have a strong feedback looping mechanism in place, and we also try to make sure that we periodically get all sorts of intelligence from the client, so that the models are also fine tuned, and the data is always updated with the right quality and scale. Now, the next slide will largely talk about the deployment architectural flow, which we typically follow. I mean, the previous slide had more granular details, but this slide will talk about flowish from a flowish perspective. So here, as you can see, first we have the device ID. So the unique identifier for the data which we use at Mobile Wallet is the device ID or the advertisement ID. So whenever we receive the device ID and the labels from the client, we try to match it up with our data sets, and then we carry a bunch of iterations as mentioned, and we do all sorts of match rate analysis, and based on that we procure the features, and we develop the models. Now once the model is built, we do a series of validation checks. We do uh, we evaluate the models at different validation data sets. Like there could be an unbalanced data, there could be a balanced validation data, and we do the validation on the training set as well. And we try to make sure that the model which we built is demonstrating the right KPIs demonstrating the right KPIs in terms of AUC, case, VNE, and other things we look up. Once that is done, we try to keep a threshold. So we typically see that any of 25 to 30% usually gives a decent model, and then it kind of fluctuates plus minus. I mean, deviations are always there based on the data set we receive, and then it's not always that our features will always be proven to be powerful in irrespective of whichever data the client gives. So it's the function of the client labels too. How well the features are capturing the labels and able to generate the right insights or able to generate the right learnings, which can be eventually you use to develop the right patterns for the defaulters class as well as the non-defaulters class. So we just to validate this, we follow this kind of mechanism, and then once all these things are passed, we finalize the model endpoint. And once that is done, uh, the next one, I think. Yeah. So we typically deploy it. Deploy it meaning we do monthly predictions on, and this frequency keeps changing, right? There could be a weekly predictions as well, and it kind of subjects to the kind of requests we receive, but there are different. This is typically based on the frequency. So once that is done, we kind of do the predictions, and then we also pull out a bunch of top significant features from the model. So let's say we have used 100 plus features in the model, and then we try to filter out at least 30 to 40 features or maybe 50 features which kind of contributes to, let's say, contributes to, let's say, 70 to 80% of the significance, and then we try to filter them out, and then we try to make sure that if someone comes back to us with a request that, okay, so this thing is working out in this way, or this thing is not working out, we can always we can always respond them back with these bunch of features so that they can try it out at their own in-house level, and do the different adjustments if required. Now, this is a part of the integration which I talked about, and next we have I mean, so there is a capability of also doing real-time application approvals and rejection when the client does it at their end. So this is something which always happens at the client interface, because let's say we have generate a bunch of features, as well as scores detailing about the different credit worthiness of customers. The client kind of uses that, integrates it with their database, and whenever there is a I mean, whenever there is a real-time application comes in, the features which we have shared alongside the risk score, they are eventually scanned through, and accordingly the decisions are made. So that's how a typical architecture follows, and it is kind of there are certain ad hoc layers which keeps getting added based on the different use case variant. But what this is typically the architecture which we follow. Now, yeah, I mean, the feedback loop is typically a quarterly. This is a basic in the best case scenario, but always try to make sure that the features are validated well at our site as well, so that the downstream impacts are minimized. So I'll take a pause and would like to know if there are any questions. Then, and I would be moving on to the next slides. So I'll take it as no. So I'll talk about the underlying data. So as Pratik mentioned about some of the typical uh, kinds of alternate data sources, which have always been proven to be powerful, and then they are being consumed day in day out by the different fintech companies. So so definitely, it is not always the credit bureau data which is the ultimate go-to source for the decision making, but the alternate data sources are proven to be very powerful as well. Now, as a part of alternate data sources, we have a bunch of variants, like it could be the telco data, it could be the e-commerce data, it could be different digital engagement data. So here at Mobile Wallah, we have a lot of features. So as you can see, there are 250 plus features. And if you look at the different kinds of feature, you can see there are household features which we use. There are different psychographic features we use. There are different carrier telco related features we use. We use a bunch of device related features. We use the app engagement features, time engagement features, location driven features, and many other kinds as well. So the reason for which we have seen these features to be quite useful is because of the breadth and depth which we have measured over time, and then definitely the rich and diversified data capturing the scale of users across the different lines of these variants have always been proven to capture a wide lens view of a borrower's characteristic profile. So we have been using a wide range of features across the different categories, and we have seen some of these categories, particularly from some of our recent experiences, we have seen that the telco features, network features, and the device related features are very strong predictors. So definitely I'll have a brief detail in some of the next slides as well, so that you can have a better understanding. So in terms of significance, I mean, based on some of our common learnings, we've tried to portray like what all features uh, have been proven to be useful, significant, and this is how the distribution looks like. But one other thing which we have learned in the past is that the power of individual features is usually not the go-to criteria which one should look up to, or the I mean in terms of client evaluation, that should not be the key thing. But we have always seen that the collective feature importance have been proven to be really useful, uh, and they have been uh, seen to be really synced well because of the typical algorithms we use, I would say, because typically you guys might be knowing that uh, in terms of linear algorithms, like if you are using a logistic regression, so you would be knowing that it throws a bunch of coefficients, and we can linearly tie up the features. Now, since we are largely using, I mean, we do use regression algorithms, but we have seen that our data I mean, have been suiting well with the boosting algorithms as compared to the other set of algorithms we have tried. And these tree-based algorithms, I mean, it's not always single feature, so it's always a bunch of features and how they fused along with the labels. They have been proven to be quite useful. So next, I'll talk about uh, some of the sample use case based insights, and this is something which came out from one of the iterations we have done for one of the institutions from a specific country, and we have tried to showcase the same shared, so that you guys can also have some kind of a reference. So based on the client data which we have used, we found that our data was able to capture a good amount of features, and here the data which we have received, it had a default rate of 13%, and it had two categories. One was one we have marked as product A, and the other one was marked as product B, because yeah, and we have and these two products are of different kinds. Now, next one. Now this is how the training data look like, and as you can see, the details of the match rate. We could see 84% match rate, meaning out of the many devices, or out of the many data points shared by the client, 62,000, we were able to match around 80 match with 84% accuracy, and we were able to capture the features of each one of them, and this was finally used for the different analysis purpose. So what we have done was using this as the data set. We have divided the data into different parts, like we have scoped 70 to 80% for the modeling purpose or a training purpose, and remaining 25 to 30% for the validation purpose. Now, within validation, also we try to make sure that the data is distributed in a balanced way as well as in an unbalanced way, so as to make sure that whatever model we have built, it's getting evaluated in the right way. So next slide, please.
Yeah, just to add what Shaurya
Yes,
said,
sure.
this is how we typically work with clients, because clients are currently in this business. They are generating data about the payment behavior, whether the customers have paid back on time or not. So what we typically do, we ask for data. Along with the data, they provide the labels. A label indicates whether the customer has paid back on time or defaulted. We use this data to train our models, and a part of this data to test our data sets. So a fintech company can say, okay, I'll give you devices for last 6 months. You create a model and give us the output. And when we train these models, and we create the model and train the models, we provide the outputs to client, which is further tested by the client. Shorja, over to you.
Sure, Pratik. Thanks. Yeah, this yeah, you have explained it well. The next one is specific to the strategy and the validation approach which we follow here. Now, this is kind of mentions about some of the learnings we have had, and the kind of model which we have eventually used to do the final set of predictions. So I think Cat Boost was the one which we have finalized on. So based on this, we have done the evaluation at two levels. One was wherein we have done the evaluation at our end on the validation set, and we have also done the predictions based on that. I mean, the model which we have finalized, and the same model predictions got evaluated at the client side too. That is the one on the test set, and we have seen that performance didn't really have a major difference. So there was no compromise, no major compromise on accepting a few cents, and it was kind of working well for the client. Now, the second stage, what the client did, it was where the model was, I mean, the predictions was the predictions which we have shared, they were used as a feature at the client side, and they were also clubbed in with a bunch of other features. It was typical. I mean, it was very much specific to the client side, and there also our predictions were proven to be quite useful. So the numbers next would help you to get the same clarified. So as I mentioned, the mobile wallet predictions, I mean, they somewhat got evaluated in similar lines, both on the holdout validation set as well as the test set for both the products. So the second one is where the mobile wallet predictions was also added with the client features. So Pratik, the next one, please. Yes, the client in-house model. In-house model meaning the in-house model as well as the bunch of features they have at their site. So here also our model was I mean our model predictions were proven to be bringing, I mean, significant, and then that had also added to some good lift. I think good live, and also the defaulters the risk associated with it in terms of the defaulters person, that was also reduced, so which is quite a good thing to quantify. So the next section, I mean, we try to uh, make it more visually appealing. So we try to think like whether we can tie some of these features and then the learnings we have gained by these kind of means. So we have tried to showcase some of the top I think top 10 attributes of the defaulters as measured across the different feature categories. Now, the first one is the what we have identified was the cheaper phones were usually being found in defaulters. So by cheaper phones, I would say that when we have measured, so we have a bunch of devices, and each device is tied to uh, the device model and then the phone price, which is associated with the handset. So we try to look at the different distribution of phone prices or the device price here. And when we tried to look at from the defaulters perspective, we found that the event rate or the defaulters rate, which was observed for the higher end phone devices with higher end phone prices, was less as compared to ones captured for the lower end phone prices. So that's where we have seen a similar trait getting displayed. uh, Same stands for some of the handset age when we looked at. So we have the phone model age as one of the features, as well as the year release as stated. We can always calculate the handsets which are newer in nature versus older in nature. And the same thing when we tried with the defaulters, we have found a similar trait. And then it makes sense that I mean, typically what we have seen is the defaulters or the ones who are into the defaulters, they always try to make sure that they 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 are not always practicing the right ways from a very established place, like in case of uh, the handsets or in terms of the affluency as stated, because this also gets tied to the affluency. So yeah. Now, the higher affinity uh, is seen towards the gaming as well as social apps. So we have a bunch of apps which can be always tied to the app categories, and we have found that these categories were more prominent as compared to the other categories, which can be music, which can be news and magazines, uh, uh, health related apps or fitness apps or sports apps and so on. Now, within games, we have found typically that I mean this is very much specific to their science side, but yeah, I mean usually the board or the card games are more prominent across the defaulters, whereas the non-defaulters were more active in the education and trivia games. So next, yeah, so this, as I mentioned, there can always be an affluency linked to the borrower's profile. So the one who is more affluent will be less likely to default as compared to one who is less affluent. So and affluency can always be linked to multi areas, like with the kind of premium apps one is using or the premium locations one is visiting, based on the data which we procure. So that's how we have tried. And now, yeah, the same thing we have tried to see it from mobility perspective, and we have found that the defaulters exhibits lesser mobility than the non-defaulters. Also, they have traveled less internationally. So this is again an insight which we have seen that the defaulters usually, sorry, the ones who are seen to be traveling a lot and also across the seas are usually seen with some kind of a good affluency behavior. So definitely that's again tied to that can be tied to a non-defaulted characteristic. Similarly, the lower engagement is seen towards the restaurant QSR QSRs and then banks. So this is again based on the engagements we have found. So the more visitations of restaurant QSR meaning the activity or the mobility is more, and that can always be tied to a non-defaulters. So yeah, this is specific to the default, the device manufacturer. So we have device manufacturer as one of the features, and we have manufacturers like Samsung, Apple, Oppo, and different manufacturers we have, and we can always find a default as percentage there. So here there we found that Samsung having the lowest default rate as compared to the others, while Oppo had the highest default rate. Now, as we have done this analysis for Indonesia, and as you may as you may be aware that Telkomsel and Smartfren are two of the, and alongside others, they are two of the big names. So Telkomsel had the lowest defaulters rate, where Smartfren had the borrowers seen with Smartfren as one of the carriers, they had been seen with a very high defaulters rate. The last one is specific to the time engagement attributes. So, the higher engagements were seen during weekdays and work hours for the defaulters as compared to the non-defaulters. So this sums up the 10 different attributes which we could finalize from the analysis we have done. And yeah, this is how it is. And so summing up in a nutshell, now that we have had a detailed session, and then particularly free to chime in whenever there is a need. So we we had a session on of both process development and learnings, and we would like to reiterate some of the salient features we have just discussed. So in terms of learn better features, they do speak a lot and chime in with the objective we have in mind. Secondly, we have a dedicated pipeline we built for solving I think the next animation. Uh, yeah, so we have a dedicated pipeline which we have built, and which we have not mentioned yet, but this definitely helps us in catering to some of the use cases we solve for the different fintech clients. So by practice, we have solved at least 50 plus use cases so far over a shorter period of time, and definitely we have this pipeline continuously integrated and developed with more such state-of-art practices. So definitely this is somewhere we are actively developing as well. The fourth point is of our multi-regional or cross-regional experience. Um, as Pratik has already mentioned that we have impressions across 40 plus countries, and for this fintech business which is growing very rapidly, here also we have so far been able to solve some interesting use cases for uh, six. So it's around 6 countries, and we have a bunch of other countries in the pipeline where we are planning to work more. Uh, and then the fourth one is in terms of the quality. Now, we always try to make sure that the results and the predictions which goes out of our premises is uh, is qualitative enough, and since we have a scale, so both the duo plays a good role, and definitely we always try to make sure that we have some benchmark set which can be uh, useful for catering to these validation practices. So yes, so this is all I had. So any questions, or Pratik, if you want to add anything, please feel free to.
Oh, I think I'm good. Let's take some questions. I see
Yeah,
some
sure.
questions being asked in the chat.
Yep. Thank you so much, Pratik and Suja. Yeah. Guys, if you have any questions, yeah, feel free to unmute yourself or just if you're shy, you can comment them in the chat box. Yeah, I think there are some questions in the chat box. So,
Yeah.
okay, the first question is, Pratik and Seja, how do you see the mobile advertising industry evolving the next few years, and how is Mobile Wala adapting to these changes?
Uh, yes, that's a good question. And the primary changes we see in the industry is due to privacy and regulations. So I hope most of you have used iPhone or have seen at least iPhone. Earlier, you could install any app and the app will start generating data. But now, if you install an app and the app will give you an SG message that it's trying to, some data is being generated or you are being which through which you can be tracked. So these are some uh, challenging questions which we have to address. Uh, Due to privacy and regulations, we see some impact in the mobile industry, mobile advertising industry. About the second part, how is Mobile Wala adapting to these changes? We have some strategies to deal with that. Uh, so let's talk about short-term changes. What we did was when the iPhone iOS changes came. These were called by the way iOS 14.2 changes. These came last year, and we saw that the volume started going down, which impacted everyone in the industry. But what we did was we increased our number of sources through which we acquire the data. So for instance, if we had X volume earlier, we ensured that we were anticipating these changes. So if we had X volume, we probably reached out to 1.5x. Now when these changes came, instead of going way low down, way below, we reached excuse me, from 1.5x to maybe 0.9x instead of 0.5x. So these are some of the strategies we employed. In long term, it's this Android may come out with the changes, but it's going to be long haul. So if you remember the cookie world, there were talks about cookies being replaced by something else or cookies not allowed. Those there were some changes, but those took a lot of time and new solutions came up. So if you were to see mobile interest advertisement industry is multi-billion dollar industry, and as soon as things become more clear, solutions will come out. There are talks about generating different identifiers in the industry, which can replace the current identifiers in the industry, which whole mobile and advertising industry relies on. I hope it answers your question.
Yep, thank you so much, Pratik. Yeah, Seja, any thoughts to add on?
So I think Pratik has covered it all.
So next question is, how do fintech lenders address issues of bias and discrimination in their lending practices? How do fintech lenders uh, so if I'm not wrong, the question is related to bias in the model. Uh, uh, so when if you look at the data which is being supplied here, we are talking about alternate data, uh, which is generated by all all people. Now, I'm sure you're referring to, the examples wherein you train your models using certain type of database data which creates bias in the model. But given the kind of data which is being used, there are not many biases. For example, if you're using device data, if you're using location data, it's all same for different kind of people, right? And when you have device data or telco data, the data comes from all type of people, so there is no inherent bias in the models. Shorja, you want to add something here?
Uh, yeah, so if I understand the question correctly, so I think yeah, so on top of what Pratik has said, um, so the features which so it's not always the data which goes out of lend better. So it's the there's a lot to do with the data which is there at the client side. So it's always so there could be a possibility that uh, client A is firstly encountering a bunch of issues, and maybe they want to improvise their models there, wherein they are sourcing a bunch of alternate data sources. So that's where we may have, I mean, that's where we do our support. And once our data is fused along with the client data, there could be a possibility that uh, that there could be some improvement in the biasness or the discrimination, or more like more like the the model which is eventually built on top of our features as well as client in-house features that develops better learnings. But but is always to do with the practice which one is following. So if the practice, I mean, in terms of the fundamental practices between one does, there could be a possibility that uh, the model is overfitting and be encountering some bias variance challenges as well. If you wanted one if you wanted to ask from that perspective. And also to add on to that, when we were explaining about the modeling strategy which we follow, we have also mentioned about the validation practice we do here. And as a part of validation practice, we try to make sure that uh, the model which comes, I mean, the model which we build that has that has an AUC or case as low as possible in terms of the difference between the training and the validation. So there also we try to minimize the bias and variance. So, do you want,
So
I mean, does that answer the question or?
just to add to what Shaw just said. See, we have to bear in mind that one of the goal of these fintech lenders, at least at high level, is also the financial inclusion of people, right? So they are trying to serve the people who till now have not been served by big banks, right? So when they give the base data, they are trying to serve that strata of people who are till unbanked, and they are trying to include as much as people they can. Now, if there are certain lenders who are very specific and in the lending practices and have bias and discrimination in the first place, yeah, then there is always a risk that the model you build using that kind of data will have inbuilt bias and discrimination. But given the goal of financial inclusion to these set of people, we believe that the data which is used to train this model is not biased.
That's right.
Uh, Next question is how location specific is lend features feature analysis? You want to take that, Shorja? How location specific is lend feature analysis? So let me cover a little bit.
Okay.
Uh, so we the lend better is nothing but library of attributes which we have found to be predictive of multiple business outcome. One of is definitely a credit risk rating, right? And to derive those library of attributes, different type of data sets are used. One is the location data, one is the app data, one is device data, then you have IP address, household, etc., etc. Shorja covered a bit of it. Now if you look at the location, that that data gives you a lot of insights about what you do, where you how do you move, where you work, etc. For instance, if I see you every day in the CBD area, you most likely work here, right? Or if I see you uh, if I see you at a certain location in the night time, I can make certain judgments about where you stay, what kind of society you stay. You know, then you have Based on location data, you can calculate something like average mobility of the person, the distance traveled by the person, the distance between home and office, different type of locations being visited by the person, different kind of location being visited by the person, whether the person is seen at the premium outlets, etc. So once you combine all this, you can generate a lot of insights about the person. So your question was how location specific is location. Yeah, there are some location based features, but there is a lot more to learn better. So as I said, that there is locations, then there is device level information, and then there's bunch of app information, etc. I hope this answers the question. If not, then please put in the chat, or you can unmute yourself and ask. How do fintech lenders differentiate themselves? So if you look at different fintech lenders, not everyone is giving same kind of product, right? Not everyone is serving the same type of clientele. So let me give an example. So yesterday we were talking to one client which has employed a peer-to-peer lending platform. So you and I or such people who have some extra cash can go out and give the loan to people. And the people would be the ones who are looking for one-time cash for small, let's say $100 of cash. Okay. Then you have products such as BNPL. I'm sure some of us use Atomy in Singapore. So if you go to if you buy something online, you can use payment method as one of the you can use Atomy as you can use Atomy as one of the payment ways. There you end up paying you pay one installment at that point of time, and you pay installment at in the next 2 months. So three installments. There are some. So the way fintech lenders differentiate is giving different kind of products, different kind of payment terms, different kind of interest rates. They serve different kind of clientele. Hope it answers your question. Please feel free to ask if it's not clear.
Does anyone have any other questions to ask, Pratik and Seja? Yeah, if not, I think that's all the questions we have. Yeah, thank you so much, Pratik and Seja, for responding to all the questions. Yeah, it was a very insightful sharing. Yeah, and thank you everyone for availing your time to attend this workshop as well. Hope you guys have learned a lot from this session. Yeah, thank you so much.
Yeah, thank you everyone. Appreciate your time.
Thank you, everyone.
Have a good day, everyone.
Yeah, have a good day. Goodbye.
Bye-bye.
Thank you. Bye.